In this video, I will explain you how to solve memory ROM and RAM interfacing problem with the help of this example. So now here this question is asked for Mumbai University question paper in December 23 and May 24. So first of all, we have to read all the statement that is given in the example. The first one is our microprocessor 8086 is working at 10 megahertz in minimum mode configuration. So you have to design our 8086 microprocessor based system with our minimum mode configuration diagram. Then the second one is the 64 KB ROM using 16 KB devices, and the third one 32 KB RAM using 16 KB chips. So first of all, I am writing here. The first one is you have to mention your MP 8086, that is your microprocessor 8086 is working at minimum mode configuration. So whenever it is working in minimum mode configuration, then your minimum maximum pin of our 8086 is connected to our VCC. Now the second one is what is given 64 KB ROM using 16 KB devices. So here we have to first of all find out total size of ROM. And the total size of ROM is 64 KB. And the available size of ROM is 16 KB. So we have noted down what is the size of RAM is total size is given, that is 64 KB, and the available size is equal to 16 KB. Now we have to find out number of chips will be required. So the number of chips will be required, we can find it out as, first of all, we will write down what is the size of total size is given. The total size of given is 64 KB. And what is the size is available, that is 16 KB. So 64 divided by 16, we got the answer 4. So here we require 4 number of chips in that ROM example. Now let's begin with our second point. So now in that second point we have to also calculate the number of sets will be required. So we are finding out now number of sets required. For finding the number of set, we can find it out as number of chips divided by number of banks. So now we got here number of chips is equal to 4, and we have two types of bank, that is even bank and odd bank. So 4 divided by 2, we got the answer 2. So here we require number of chips is equal to 4 and number of sets is equal to 2. So here we have found it out number of sets will be required. So we got the answer 2. So there are 2 sets will be there, and in the one set we have the RAM and ROM architecture, that is even and odd ROM set 1. And in the second one we are writing here even and odd ROM set 2. So these 2 sets will be considered while solving that example. Now next one is we have to identify IC number and number of address line. So how we are finding the number of address line? First of all, write down here number of address lines required. So there is 16 KB of data, that is the size of available ROM will be available. So I am writing here 16 KB into 1024 memory location, because 1 KB is equal to 1024 memory locations will be available. So 16 KB is nothing but we are writing here 2 raised to 4 into 2 raised to 10. So 1024 is nothing but 2 raised to 10, and 16 KB is equal to 2 raised to 4. So 2 raised to 4 into 2 raised to 10, we can write it here 2 raised to 14. So here we got the answer 14, so that we are writing here 14 address lines required. And we are writing here the address line number, that is from A1 to A14. Now next one we have to find out IC number. So IC number is equal to 16 KB into 8 bit. So 16 into 8, we got the answer 128. And here I'm writing this 128. And for our IC number, we have to write down it for ROM. The IC number for our ROM will be whatever the number we got, that is from our previous calculation, we are appending to the prefix of our IC number. And the prefix for our IC number is 27 for our ROM and EPROM. So 27128 is the IC number that we are using for our EPROM. In the example, ROM is given, so I am writing here ROM. So here in the second example, second point, we have calculated the available size is given and the total size is given. Depending on we have calculated, the number of chips will be required. Then number of sets will be required. Number of address lines will be required and the IC number for our ROM. So whenever you are considering here the address number, you have to start it from A1 to A14. Because in the previous example, we have already seen that there are two types of memory banks will be available. So the first one is even memory bank and the second one is odd memory bank. So in case of even and odd memory bank, the even memory bank is connected to our edge and odd memory bank is connected to our bus high enable signal line. Now in this example, the third point is given, that is 32 KB of RAM using 16 KB chips. So how we are solving this one? The first one is we have to write it down, 32 KB RAM using 16 KB chip. So I'm writing here the total size of our RAM and the available size of RAM. So the total size of our RAM is 32 KB and the available size is equal to 16 KB. Now I have to find out number of chips will be required. So number of chips will be required as the total size divided by the available size. So the total size is 32 divided by 16 and we got the number 2. So here we require 2 number of chips. Now we are identifying number of sets will be required. So in this example, there are 2 chips we got from the previous calculation. So I'm writing here number of chips divided by number of bank. So we have 2 types of banks, even memory bank and odd memory bank. And we got the number of chips is equal to 2 and the number of bank is equal to 2. And we got the answer 1. So one set of RAM and ROM will be available, that is even and odd set 1. Now we have to calculate number of address lines will be required. So how we are calculating this number of address lines? We have 16 KB of data will be available. So this 16 KB into 1024 memory location. So I'm writing here 16 KB into 1024 memory location. So 16 KB is nothing but 2 raised to 4 into 1024 is nothing but 2 raised to 10. So 2 raised to 10 into 2 raised to 4, we got answer 2 raised to 14. So here 14 address lines will be required. So I'm writing here 14 address lines will be required so that our address lines will be A1 to A14. So these are the address line number that we got from our RAM chip. Now we have to find it out the IC number for our RAM. So here I'm writing the IC number is equal to our 16 KB into 8 bit. So 16 KB into 8 bits, so 8 bit ports will be used for our input and output devices, so that we are multiplying the 16 KB into 8 bit. So we got the number 128, and for IC number we are using the prefix for our RAM is equal to 62, and we are appending whatever the number we got from our calculation, that is 128. So our IC number for our RAM is equal to 62128. So we have done with our calculation part. The three statements are given. Based on that three statement, we have calculated number of chips will be required, number of sets will be required, and number of address lines will be required, and what is the IC number for our RAM as well as our ROM. Now we will begin with our actual drawing of our memory interfacing with our 8086 microprocessor and our RAM and ROM interfacing structure. So here the minimum mode configuration will be there. So we require the diagram for our minimum mode configuration CPU of our 8086 microprocessor. Now we will draw the diagram for our configuration that is given in that example. So this is the diagram for our minimum mode configuration, and we have drawn our EPROM as well as our SRAM. So in this example only ROM structure is given. So I am renaming here the ROM, and here instead of SRAM, I am writing here RAM. And the sets will be available, that is two sets will be there, that is two memory banks will be there, that is odd memory bank and the even memory bank for our ROM and the RAM structure. So the IC number that we are using, that is 27128 for our ROM and 62128 for our RAM structure. That is calculated previously in that example. So now you can say that there are two sets of ROM will be available, that is set 1 and set 2. And here there are two sets of ROM and RAM we have identified from this example. So first we are considering here the ROM structure. So in the ROM structure there are two sets, set 1 and set 2. And the number of chips we require, that is 4 chips will be required in this example. So how these 4 chips will be required? Whenever we are considering this set 1, then it consists of two types of banking, that is even memory bank and the odd memory bank. Whenever we are considering this set 2, it also consists of two types of banking, even banking and the odd banking. So whenever we are drawing in that diagram, we are writing here the odd bank and we are writing here the even bank. But we have two sets are available for our even as well as our odd set. So here you have to draw the structure. So whenever I am drawing the structure in our diagram, then odd plus one set will be there. So odd and odd, it will become two odd sets will be there. And here even and even, this will become two even set will be there. Otherwise, you can draw the four blocks like this one is for odd, this one is for even. This is odd 1, odd 2. This set you are considering as odd 1. This set can be considered as odd 2. This is for even 1 and this is for even 2. As like way, you can also draw the structure in our diagram. The first structure will be this one and the second structure will be this one. You can follow any one structure while drawing the diagram. So I am following this first structure while drawing the diagram. So here there are 4 chips will be there and the 2 sets of even and odd memory set will be there in the ROM structure. So I'm writing here in that ROM and I'm drawing this symbol here so that my even and odd set will become 2 plus 2 is equal to 4 set will be available. 4 chips will be available in our ROM structure. In case of RAM structure, you can identify it as even and odd set of one set will be required. So we have already with that one set, that is for RAM odd structure and RAM even structure. So there is no need to draw the symbol for our RAM structure. Now what we are doing, we are extending this line, that is bus high enable signal, then our address line, then our data line, then our memory read signal and the memory write signal. So how we will draw this diagram now? Whenever we have to draw the diagram, that time first of all you have to consider the read and write signal for our ROM and the RAM. So whenever you are considering the ROM structure, then it consists of only read symbol. So I am writing here the read symbol and we are connecting the read line to our ROM structure. And you have to give the name here, that is read bar. So this signal can be considered as a read bar signal. And the same structure you have to draw in our ROM also, ROM set 2 also. Now you have to connect the read and write bar signal, that is these two lines in our RAM structure. So I am connecting here read symbol. This is also read symbol is connected to our RAM structure, and this line is there for our write structure. The write connection will be there. So I am connecting here the write symbol, and this is also our write symbol. So I am writing here read and write signal that are available in our RAM set of structure. So you can write here whatever you have given the connection in the diagram, that is RD bar and WR bar. And the same you have to give it to our address line of our data bus as well as our address bus. So now we have completed till our read signal and the write signal. So here you have performed this interfacing with the help of this read and the write signal. So you have to remember that the read signal is available only in our ROM structure and read and write signal will be available in our RAM structure. Now we have to connect to the address line. So here you can check how many address line will be required in our ROM. So there are 14 address line will be required in our ROM structure, and in case of RAM also we require the 14 address line. So I am connecting this address line here, and we have to give the connection for all the block. And we have to write here whatever we have given, that is address line 1 to address line 14. Here also same you are writing address line 1 to address line 14. Whenever you are considering the read signal, and the read signal will be considered as the two sets of signal will be there in our read and write bar. So that you have drawn in this structure. Now you have to go with the data lines. So how you are connecting this data line? First of all, I am drawing with that data line. In each and every block will be there for our SRAM as well as our ROM structure. So I am connecting all this data line here. And this data line is bidirectional symbol. So I am giving this bidirectional symbol to our each and every set of our data line. So now we have to remember one point. Whenever we have two types of banking, that is even and odd memory banking, the data line will be connected, that is our D8 to D15 line will be connected, that is our higher order data bus will be connected to our odd memory bank, and our lower order data bus will be connected to our even memory bank. So how you can write down here the data lines? The first of all, you have write down this D8 to D15 in our odd memory bank, then D0 to D7 in our even memory bank. So I'm giving the number as D0 to D7. Here also I have to write for odd D8 to D15, and for even I'm writing here D0 to D7. So now we have done with our connection for our read and write signal, then address bus and the data bus. Now we have to check that what is the even and odd memory bank selection in our diagram. So now let's check with our diagram and how we are connecting this line. So in this diagram you can see these are the total 8 cases will be there, that is up to 000 to 111. So these are the total 8 output signals are there, that is from Y0 to Y7, and these output signals are available in that 7 to 74138 this latch, that is 3828 decoder. And we have right here A, B, C, these are the input lines, and we are considering here the A19, A18 and A17, these are the address lines will be available. And in this diagram we have used total 14 address lines, that is from A1 to A14. And our 15 and 16 signal that is available, and that we are considering it as a D signal. So I am taking here A15 and A16. These two signals I am considering here, and that I am giving it to the D signal. So these two input will be given to our D data, and that are considered as a one input. Now we have to check here this total 8 cases for our truth table. So 000, this will be selected for even and odd set of our RAM. Then 001 will be used for even set of RAM. 010 will be used for odd set of RAM. And 100 will be used for even and odd set of our ROM. 101 signal will be selected for our ROM signal, even ROM signal, and 110 will be used for our odd ROM signal. So now you will see how the signals will be selected. So this is the chip select signal, and this is connected with the help of OR gate to our odd and even bank of our ROM and RAM structure. You can see here for the odd memory bank, we are attaching this burst high enable signal, and for the even memory bank, we are attaching here the A0 signal. So this is our odd bank. For the odd bank, I am writing here burst high enable signal. This is also our odd RAM. So I am writing here burst high enable signal. And for the even memory bank, I am writing here A0 signal. Now one connection is remaining, that we have to give the odd selection for our ROM structure. So for the odd selection, either I can write the connection 4 or 6. This will be selected lines for our odd signal, that is odd memory bank, and for the even memory bank, I am writing number 4 or 6, number 4 or 5. This will be selected lines for our even memory bank of our ROM structure. And whenever I am considering here the RAM structure, there are also two types of banking, that is odd memory banking and the even memory banking. For the odd memory banking, I am selecting either 0 or 2. And for the even memory banking, I am selecting 0 or 1. And this will be selected for our RAM structure. So now here one line is pending, one connection is pending. That is one input line will be selected based on that odd selection of our ROM. So I'm writing here Y4. So I have selected this 4th number signal. Now in case of even memory signal, I have to select again one line. So I'm selecting here Y5. Now for the RAM structure, I require again two inputs. So I'm selecting here 0 for odd and 1 for even. So you have to write here Y0 and Y1. So now the diagram will be completed and we have drawn the structure for our minimum mode configuration, and this configuration consists of this RD bar signal as well as memory read signal, then our write signal. So these are the two low signals will be available, that is RD bar and WR bar. This is our data lines, that is from D0 to D15. And this is our address line, that is from A0 to A19. And this is our bus high enable signal. This is also activated in our connection. So with the help of this technique, we have drawn the memory interfacing diagram as well as our truth table for even and odd set of our RAM structure. So in this way, you can solve this 10 marks question in our exam. So this type of question can be asked for 10 marks in the exam.